Welcome to Session 04. This session builds the AI-specific foundation every tester needs, the 5 families of AI that show up in testing, where language models actually fail, a 7-part prompt formula that forces structure before generation, and a verification loop that treats every AI output as a draft until you prove otherwise. AI in testing is not one tool. It is 5 different families, each solving a different problem. Generative AI analyzes requirements, writes test ideas, generates code, creates data, and summarizes defects. Machine learning predicts which areas carry the most risk, prioritizes what to test next, and clusters failures by root cause. Computer vision compares user interfaces by meaning, not pixel position, so a button that moves 10 pixels does not break your test. Reinforcement learning agents explore application states through action and feedback, finding paths a human tester might never try. And self-healing frameworks attempt to relocate a broken element or recover from a conditional failure. Mixing them up means measuring the wrong thing. There are 3 distinct scopes, and confusing them derails your strategy. First, using AI to test conventional software, generating scenarios, writing assertions, exploring edge cases. Second, testing the AI system itself, data quality, model bias, robustness, safety. Third, using AI to support quality engineering activities broadly, summarizing test runs, triaging defects, estimating risk. This course focuses on scopes 1 and 3. Scope 2, testing AI systems, is a specialized discipline with its own metrics, and mixing it creates confusion about what you are actually measuring. Here is the single most dangerous misconception. A language model is not a database of facts. It predicts what output fits the context you gave it. That prediction can invent an API that does not exist, a CSS selector that matches nothing, a requirement the product never had, or an expected result that sounds right but is wrong. And the same prompt can produce a different answer on the next run. So what is the actual source of truth? The requirement document and the executable behavior of the system. Code must run in a real environment. Assertions must be confirmed by a human. And every change an AI produces must be reviewed exactly as you would review code from a new team member. A good prompt has 7 parts. Role: tell the model who it is, like you are a senior QA designing tests. Context: the application, the user, the business rules, the platform. Input: the actual requirement text and any confirmed assumptions. Task: what to generate, using which technique. Constraints: do not invent, mark open questions, no real user data. Format: a table with ID, precondition, steps, expected result, priority, and source. Criteria: must include positive, negative, and boundary cases with no duplicates. Structure forces the model to generate within boundaries. Without it, the model fills every gap with its own imagination. Here is a safe prompt in action. It tells the model to analyze the requirement below, and to first list every ambiguity and every question that needs a product owner answer. Only after that, generate test scenarios from the information that is certain. Each scenario must trace back to a specific sentence in the requirement. And if the expected result cannot be determined, write needs_confirmation, do not guess. This pattern catches hallucination at the source. Without the mark unknown instruction, the model fills gaps with plausible fiction, and you ship an assertion that tests something the product was never supposed to do. Generation is a draft. Value only arrives after verification. Step 1. Review the requirement and every assumption the model made. Step 2. Check that each scenario adds value and that none are duplicates. Step 3. Verify the test data, the permissions, and the application state. Step 4. Actually run the code and read the failure output. Step 5. Compare each assertion against the business intent, not just the requirement text. Step 6. Log the prompt, the model name and version, the date, and any changes the reviewer made, so the output is auditable. Skip steps 4 and 5, and you have a green CI pipeline that proves nothing. For cognitive traps catch testers who work with AI. Automation bias, you trust the output because it reads fluently, not because it is correct. Confirmation bias, you use AI only to reinforce what you already believe, never to challenge it. Coverage illusion, the model generated 20 test cases, but 12 of them test the same behavior with different wording. False confidence, the test passes because the assertion is too weak or because the test never actually exercised the code path it claims to cover. Each of these erodes the suite silently. The tests are green, and the bugs ship anyway. The practice exercise makes these ideas concrete. Take the login requirement from session 01 and prompt the model twice, once with a single unstructured line, once with the 7-part formula. Then score both outputs on 5 axes: number of ambiguities discovered, number of valid unique scenarios, number of duplicate scenarios, number of expected results the model invented, and the time you spent reviewing. 20 generated test cases is not a quality metric. 5 valid, traceable, non-duplicate scenarios with no invented expectations, that is the metric. Session 04 gave you the AI map, 5 families, 3 scopes. The truth rule, a language model predicts, it does not know. The 7-part prompt formula. The 6-step verification loop. And the 4 cognitive traps that make green suites ship bugs. Session 05 layers in spec analysis and test design with AI, turning real requirements into structured, traceable, reviewable test scenarios.